Have you ever looked out of an airplane window and wondered how a machine weighing hundreds of tons can race down a runway and suddenly lift into the sky? Every second, a jet engine swallows enormous amounts of air, compresses it, ignites it with fuel, and unleashes incredible energy. But here's the surprising part. Despite all the flames inside, the engine doesn't actually push the airplane forward the way many people imagine. Instead, it relies on one of the most fundamental laws of physics. Today, we're going inside a modern jet engine to discover exactly how it generates thrust, why its spinning blades don't simply act like giant fans, and how engineers transformed one of humanity's oldest dreams, flight, into one of the greatest engineering achievements ever created. Chapter 1. What is thrust? To understand a jet engine, we first need to understand thrust. Thrust is simply the force that moves an aircraft forward. According to Newton's third law, every action has an equal and opposite reaction. When a jet engine throws a huge mass of hot gases backward at tremendous speed, the aircraft is pushed forward with an equal force. It's similar to letting go of an inflated balloon. The escaping air rushes backward and the balloon shoots forward. A jet engine follows exactly the same principle, but on an enormous scale. Every second, modern engines accelerate hundreds of kilograms of air, producing enough force to lift aircraft carrying hundreds of passengers across entire continents. Chapter 2. Air intake. Everything begins with air. As the aircraft moves, massive amounts of air enter the front of the engine through the intake. A large commercial jet engine can ingest over 1 ton of air every second during takeoff. The intake isn't just a hole. Its carefully designed shape smooths and directs airflow, reducing turbulence and delivering air efficiently into the compressor. Without a steady stream of air, the engine simply cannot operate.
Chapter 3. The compressor. Once inside, the air reaches one of the engine's most important components, the compressor. Rows upon rows of rotating blades squeeze the incoming air into a much smaller volume. Compressing air dramatically increases both its pressure and temperature. Think of using a bicycle pump. As you force air into a smaller space, the pump becomes warm. A jet engine performs this process continuously, using multiple compressor stages. By the time the air leaves the compressor, its pressure can be more than 40 times greater than when it entered. This high-pressure air is essential for efficient combustion.
Chapter 4. The Combustion Chamber. Next comes the combustion chamber. Fuel is sprayed into the compressed air as a fine mist. Igniters create the initial spark, but after startup, the flame keeps burning continuously. Inside the combustion chamber, temperatures can exceed 2,000 degrees Celsius, hot enough to melt most metals. So how doesn't the engine melt? Engineers solve this problem using advanced nickel-based superalloys and sophisticated cooling techniques. Tiny holes in the combustion chamber walls create a protective layer of cooler air that shields the metal from extreme heat. It's one of the most impressive engineering solutions in modern aviation. Chapter 5. The Turbine. The expanding hot gases now rush into the turbine. This section looks similar to the compressor, but works in reverse. Instead of consuming energy, the turbine extracts energy from the hot gases. As the gases flow through turbine blades, they cause them to spin at astonishing speeds. The turbine is connected by a shaft directly to the compressor at the front. That means the turbine powers the compressor without requiring any external motor. In many engines, these shafts rotate at more than 10,000 revolutions per minute. Despite the enormous energy extracted, plenty of energy still remains in the exhaust. Chapter 6. The Exhaust Nozzle. Finally, the remaining hot gases exit through the exhaust nozzle. As the nozzle narrows, the gases accelerate dramatically before shooting out the back of the engine. This extremely fast exhaust creates the reaction force we call thrust. The faster the exhaust leaves the engine, the greater the forward force acting on the aircraft. Every phase, from air intake to combustion to exhaust, is carefully optimized to maximize efficiency. Chapter 7. Why modern engines have huge fans. If you've flown recently, you've probably noticed the enormous fan at the front of modern engines. Many people think this fan alone pulls the aircraft forward. That's only partly true. Modern commercial aircraft use turbofan engines. The large front fan moves a massive amount of air around the engine core instead of through it. Most of the thrust, often around 80% to 90%, actually comes from this bypass airflow rather than the hot exhaust. Moving a large mass of air at a lower speed is much more fuel efficient than accelerating a small amount of air to extremely high speeds. That's why modern engines are quieter, cleaner, and more efficient than earlier turbojet designs. Chapter 8. Engineering at the Edge. A modern jet engine is one of the most sophisticated machines ever built. Its turbine blades operate in temperatures hotter than molten lava while spinning thousands of times every minute. Blade tips travel close to the speed of sound. The clearances between moving parts are often smaller than the thickness of a coin. Thousands of sensors constantly monitor temperature, vibration, pressure, and performance to ensure safe operation throughout every flight. Engineers spend decades refining tiny improvements that save even 1% of fuel, because across thousands of flights, those savings become enormous. The next time you board an airplane, remember that beneath the wing is far more than just a powerful engine. It's a masterpiece of physics, material science, thermodynamics, and precision engineering. Every takeoff represents millions of hours of research, countless engineering breakthroughs, and the elegant application of Newton's laws. From swallowing massive amounts of air to producing incredible thrust, the jet engine remains one of humanity's greatest inventions, quietly carrying millions of people across the skies every single day. If you enjoyed discovering how a jet engine works, don't forget to like the video, subscribe to the channel, and let us know in the comments what engineering mystery you'd like to explore next.